If you broke a bottle and it breaks into splinters over the floor, if you just weigh all the splinters together, then this will be equal to the weight of the bottle that we initially had. This equation between this equation of mass between this equation of mass is called the conservation of mass. That is, the weight of the bottle before the action and after the action remains the same. Likewise, if there is a bomb that got blasted, then if you just combine all the matter that existed in it and the matter that actually existed before the bomb exploded, that remains the same. And the energy that got exhausted in that bomb blast is equal to the latent energy in that bomb. This is called conservation of energy. Now, before Einstein, there were literally two worlds in this world. One world of energy, one world of matter. All that matter is the mechanical part and mechanical things, and all that energy related things were thermodynamics and all the energy stuffs. And they all were conserving in their own world, in the conservation of mass and in the conservation of energy. Totally bipartite universe. And that was the question that Einstein had in his mind throughout when he discovered the connection between the mass and energy. That famous equation was termed as the special theory of relativity. That mass and energy are interconvertible. That was the landmark theory. And it became the seed for the nuclear bomb, for the nuclear research later on. Now, why am I telling you all this here? There is a deep philosophy in this theory. Basically, the quest that Einstein had. And it did not stop at special theory of relativity, that the energy and mass is one and the same thing, just the two forms of one and the same thing. After the special theory of relativity, Einstein got into the third dimension, that was the space. What is the relationship between space and matter? Now, matter and energy, they were one and the same thing actually. Then what is the space and what is the matter? What is the common thing between these two? Okay. Now, this is something like saying what is common between an object and an empty object. Space is in absence of matter. Matter is the object. Matter and absence of matter. Object and empty object. Matter and space. What is common between these two? How these two are related? Now, apparently this looks like an absurd question. Like initially, what would you have thought when you were introduced to concept of negative numbers? What is negative number? You had one cattle, two cattle, three cattle. What is that? Minus two cattle or minus three cattle, minus 4 money or minus 10. So that looks absurd initially, but later on it came out to be very important in mathematics. Likewise, in the quest for the complete truth, you don't know what is complete truth. This whole universe is made up of two things, the matter and the space. And before Einstein, it was matter, energy and space. Matter and energy was the same. So it was just essentially two things, the bipartite system, the space and the matter. Now the theory of causation is everything that exists must have been created. It is not possible that something happens on its own. It has to be created. It should have been created. And if it has been created, then there has to be a common source. So what is the common source between the space and the matter? Einstein stopped at a very tangential point, actually, in the point where he was able to make some relationship between mass and space, and that relationship was also very significant. What it said was, space is like, space gets curved, space gets defined by the mass. So if there is a huge mass, then space gets curved near it. Okay, and the proof for that was, like, if the ray of light ray of light has to go straight, right? Because it goes straight in the space, and space is linear as per our knowledge. But when there is a huge mass, then the ray of light tends to get bent because the space is bent. Ray of light is right in going straight direction, but the because of presence of mass, the space got curved. Now you consider the space to be like a sheet, okay, and on that sheet a huge mass has been kept. Then what happens? The sheet tends to shrink at the point where mass is there. So if the light is passing through the space without that mass, then it would have been straight. But because of that mass, it got curved. So that was the tangential point where Einstein stopped. He was not able to find out the common point between the space and the matter. But in Vedanta, it has been long known in Vedanta that the space and the matter, everything is created from one common point that is called Sat. Sat. Now there is no corresponding English word for this, but you can say, first of all, in Vedanta, this whole universe, is actually bipartite. One is the Purush, that is the consciousness, and the second is Prakriti, that is the space. Okay. Now this Purush and Prakriti, in the combined form, they create the space and the Panch Mahabhutas. So ideally speaking, the question of what is common between matter and antimatter, what is common between the space and the matter, is actually threefold question. There is one more dimension in Vedanta, that is the consciousness. Now in Western philosophy, consciousness is incidental, but in Vedanta, consciousness is not incidental. It is all pervading. There is a super consciousness that is the common consciousness of the entire universe, and one person is actually just a small fraction of that super consciousness. Okay, and that small fraction of consciousness, along with the matter, creates a person. Okay, in Western philosophy, the consciousness is just an incidental thing that happened to happen because of a long time of evolution. But it is not so in Vedantic studies.